Welcome to another MTD Technical Corner. Now today we're going to be talking about hyperMILL. Justin, you've brought in two components here, and what surprises me is they don't look like a basketball net, a helmet, a stiletto that you normally see and people know and love, showing off the demonstration of the kind of the power of hyperMILL. Why you've brought these two kinds of components today?
There's such a wide range to hyperMILL. We've got such a broad number of toolpaths. There's 23 toolpaths just in 3-axis. So we wanted to bring these just to add some more depth to show the range of parts that we can do in 3-axis.
And the range of parts, I mean, it's huge. You see on the left-hand side here is kind of like a simple 2.5 axis with a little kind of a gradient on it. And also, this is a really complex part to be doing just in 3-axis. Let's talk about how these parts will be programmed in hyperMILL, starting with, I guess, the simpler
component. So that's what's probably classed as a prismatic component. You'd probably be just feature finding it, looking for pockets, holes, tapped holes, profiles, etc. And then you can either program to those manually, or you can even look at automation to just do that sort of simple programming for you. That component is actually a customer component. Most of that is done with 3-axis toolpaths. Again, we've got such a wide range of toolpaths. That most of that is achievable.
Brilliant. And let's talk more about how hyperMILL can make sure companies are competitive, not just doing the complex 5-axis jobs that most machine shops don't really see that often. How do they stay competitive with doing kind of simpler jobs like this in hyperMILL?
So with that part, for example, if you're into, say, the production environment, which we may not be the first thought for, you could be looking to automate that because it's a very feature-based prismatic part. But that said, you can also automate that level if you really wanted to go to that extreme.
And so moving on to the kind of more complex components, how can machine shops stay competitive using hyperMILL on a really complex component like this?
Yeah, okay, so that customer, one of the reasons why they approached us and chose hyperMILL was the performance benefits. So whether it's an engine block or a 3D component with lots of surfaces in it, hyperMILL doesn't slow down as you get quite a long program. You get lengthy programs when you do components like this. So that was the one area. They also interested in surface finish. It's the way we can blend the toolpaths as they join together. So we've got some very nice technology for that. We've got some very nice technology to control the surface finish, to really give you that mirror finish if you want it. And these are just tick boxes. It's all standard in the product. Another feature they liked was that component in particular is mirrored. It's got an identical pairing. So we have live associative mirroring. So as you change your main master program, we have a virtual one that's being mirrored live with it. So it was all about time-saving benefits for them.
Absolutely. And it's not just the productivity in programming these components. There's more of a kind of a benefit from starting with hyperMILL from the ground up if you're starting a machine shop and developing yourself in technology.
Exactly. I mean, we do have a few startups approach us who only have a VMC and possibly a lathe, and maybe that they've got prior knowledge of hyperMILL, and they're choosing hyperMILL because their vision is to grow and add a 4th axis or maybe get more machines. So then they're only investing once in training the staff, post-processors, going through building up your tool store. You know, you can always add with hyperMILL. You're safe that you can future-proof.
So it's not just hyperMILL for high-performance machining in 5-axis. If you're going to finish with hyperMILL, maybe you should think about starting with it too.